Today we are starting the new chapter, measurement. And in measurements, we will discuss some topics like units, dimensions, use of dimensions, significant digits, least counts, and errors. As we have already discussed that physics is the study of nature and its laws, and mathematics is the language of physics which helps to understand the concept of physics. Physical quantities are the number or the set of numbers used for quantitative description of a physical phenomena. And we can divide these physical quantities in two categories. Number one, fundamental quantities. Fundamental physical quantities. And number two, derived physical quantities. These fundamental physical quantities are also known as base quantities. These are 7 in numbers. First, mass, length, third, time, fourth, temperature, fifth, electric current, sixth, luminous intensity, and seventh is amount of substance. And all other quantities which are derived from these fundamental or base quantities are known as the derived physical quantities. For example, speed, velocity, acceleration, and all others. These physical quantities are required to be measured, and for measurements, we require the units. Units are the established reference standards used for measurements. And these units are of two categories. One are fundamental units, or we can say these are the unit of fundamental quantities. And second are derived units. These fundamental units are 7 in numbers, and these are meter, kilogram, second, Kelvin. This is K for Kelvin. Ampere. This is the unit of electric current. Candela. This is the unit of luminous intensity. And last one is mole. This is the unit of amount of substance. Meter is the unit of length. Kilogram is the unit of mass. Second is the unit of time. Kelvin is the unit of temperature. A is the ampere. It is A stand for ampere. It is the unit of electric current. And CD candela. It is a unit of luminous intensity. And all other units of the derived quantities are known as the derived units. For example, speed. Speed is defined as the distance by time, and its unit is meter per second. Unit of distance is meter and unit of time is second. This is the fundamental unit. This is also fundamental unit, and speed of unit of speed is defined in terms of fundamental unit as meter per second. So meter per second is the derived unit of the speed. Velocity, it is also meter per second. Acceleration, it is the rate of change of velocity. Its unit is meter per second square. Force, F equal to ma. It is the formula which we will discuss in Newton's law of motion. Its unit is kilogram meter per second square. So all these units are the, and many more physical quantities, all these units are the derived units. Other than 7 fundamental units, there are 2 more units which are called supplementary units. These 2 supplementary units are unit of the plane angle and unit of the solid angle. Plane angle. Plane angle is represented by theta and other is solid angle. It is represented by omega. Plane angle is the angle in the 2-dimensional plane and solid angle is the angle in 3-dimensional space. That means if we sum the angle, plane angle around a point, then it will cover 2 pi angle. The sum of total angle around a point in a plane is the plane angle and it is equal to 2 pi, while the total angle around a point in the 3-dimensional space, it will be the 4 pi angle. Plane angle can be defined as angle equal to arc by radius. For example, this is a circle. Circle is a 2-dimensional figure, or it is a figure in 2-dimensional plane. It has a center and a radius r. If we make an arc, say A to B, this A to B is the arc. This arc subtend an angle at the center, this is theta. This theta is the plane angle, and this plane angle is theta equal to arc, that is the AB, by radius. Radius is the r. This is the radius of the circle. So we say theta equal to AB can be written as L and it is by r. So in this way we can define the plane angle. Similarly, solid angle is the angle around a point in 3-dimensional space, and total of the sum is 4 pi, and a particular solid angle, it is subtended by, plane angle is subtended by a length of arc, and solid angle is subtended by an area of surface. It means it is defined as delta S oblique r square. This is the solid angle. And plane angle is theta equal to L by r, arc by radius. So in this way we have 7 fundamental units and 2 supplementary units. Next we take dimensions.